So we have learned about the structure of the atom, and we've learned that what are the isotopes. Just reminding that isotopes are same atoms, same chemical element, but so what determines what a chemical element is? Number of protons. So they have same number of protons but different number of neutrons. And we thought that in the nucleus there are two forces fighting each other. One is force of electric repulsion. Positive protons, they repel. And what's fighting against it is a strong nuclear force, which is attraction between the neutrons and protons. And those forces for nucleus to be stable need to be balanced. If they are not balanced, the nucleus becomes unstable and it will decay. And today we're looking into the types of decay. There are a few different types of decay. And first, alpha decay. Alpha decay. Alpha decay is when from the nucleus, unstable nucleus, it shoots out the alpha particle. Alpha particle is a nucleus of helium-2, 4. Reminding, bottom one is atomic number, top one atomic mass. So it consists 2 protons, and because it's 4 protons and neutrons, means 2 neutrons. So alpha particle is the nucleus of helium. And general equation, nuclear equation we can write. So we get element A with the, let's say, N and M. And when it shoots alpha particle out of it, it turns into different element, element B. What will be the atomic number now? N-2. Yeah, because it's lose 2 protons, we have 2 protons less, and M-4. And it could be n plus neutrinos, energy, but we focusing now on this part, so we're not looking into the neutrinos or antineutrinos which are emitted during this decay. And this is a general equation. Example of the alpha decay, for example, if we have radium 88 222 and it's emit alpha particle, what will be, open the periodic table, okay, look at the periodic table. What element it will become now? What element it becomes now?
Acid.
No. We have minus 2.
88 minus 2, 86.
86. Radon. It was 88, becomes 86, it's radon, and 218. So that is an example of alpha decay.
Okay.
Another type of decay is beta decay.
Oh, so it's alpha decay, it's always with helium.
Yeah. Alpha, what we call alpha decay, it's when the alpha particle is thrown out of the nucleus in terms, in order to become more stable.
Okay.
Beta decay. And that happens when electron, beta particle, is same, another name for electron. And electron has charge -1 and mass we take as 0. It's not 0. It's 9.1 times 10 to the 31 kilogram, but it is about 2,000 times lighter than proton and neutron, so we can consider it as 0. So that's the same. Beta particle is electron. And the equation will be, we have element X with N M. If we have beta particle ejected, we have what happens with atomic number?
+1.
Because this 1 minus 1, 0. So we have element Y, which will be N plus 1. It's increased by 1, mass unchanged.
Wow.
You may ask, where the electron coming from? Are there any electrons in the nucleus? No, there's no electrons. Then how electrons is shoot out, is ejected from the nucleus? If it's not there. Because subatomic particles, they can turn one into another. And that's happened that one of the neutrons turn into the proton. We have neutron, 0, 1. We have electron ejected, minus 1, 0. And proton left. So we have no change overall. Has to be atomic number has to be conserved and atomic mass. So when we have beta decay, the one of the neutrons transforms into the proton. Example.
Sounds good.
Example is, let's say, sodium 1124, eject electron, and what it turns into. Atomic number becomes 12,
Magnesium.
and it becomes magnesium. And plus neutrino, but as I'm saying, neutrinos, we not look into that at least for now. So there's a second type of the decay. The next type of decay is positron decay. Positron decay or beta plus decay. Beta plus decay. It is when the positron is ejected from the nucleus. Positron is, in fact, it's anti-electron. It's exactly the same as electron in all senses, except it has positive charge. Same mass, all probably the same, just positive charge. Later on we will learn that when positron and electron, if they collide, they annihilate, they stop to exist, completely turn into the energy. That's matter and antimatter. But that's later on. So beta decay we have X and M. We have positron emitted 1, 0. So what's left will be N minus 1 and same mass. Example of the positron emission is when we have, let's say, boron 5,8. We have positron emitted, and what's left, look into the periodic table, what it will be. It turned into
Beryllium.
beryllium.
Haha, off the top of my head.
Good. Turn into the beryllium. Now again, there is no positrons in the nucleus. Where it's coming from? What happens? You guess.
Neutron.
We have proton turns into the neutron this time. Before we had for beta decay or electron decay, we have neutron turn into the proton.
Proton this time.
Now we have proton 1, 1. It's turned into the neutron 0, 1 plus positron 1, 0. Now, another type of the decay is gamma decay. Gamma decay is a bit different to all other types of decay because there is no change in the chemical element. It remains as it was. Gamma decay. Gamma decay is when nucleus just send gamma ray or gamma pi, which is electromagnetic radiation. In this way, it's like shred extra energy, and as less energy it has, the more stable it is. So we have X and M, and it remains X and M plus gamma, which is 0, which is electromagnetic radiation with a very high frequency. Very high frequency and very short wavelengths, shorter than X-rays. There is also another type of decay, neutron capture, but this one we will learn later on, because as a result of that, what might happen is the nuclear fission. So when you look into nuclear fission, you look into the neutron capture. When nucleus capture neutron and then fall as a result. So those are types of decay. And when you will be writing nuclear equation, you need to balance them. You must have on the left atomic number on the left, sum of the atomic numbers of the left must be equal sum of the atomic numbers on the right. Atomic mass on the left has to be the same as atomic mass on the right. And what are the properties of those types of radiation? They call it radiation. Alpha particle. Alpha particle is heavy relative to other alpha particle. So, as it's heavy, and we will be considering two results of the effects of the radiation. We will look into the ionizing ability and penetration ability. And ionizing ability, penetration ability. What does it mean, ionizing? Make an ion. So what happens if some radiation particle hit another atom? And it's kick out electrons. Other atom becomes ion. And because alpha particle has very big ionizing ability, high, because it's heavy and can kick on. Penetration ability, because it is heavy and collide, like strongly collide, it loses its energy very quickly. So it's very low penetration ability. You can protect yourself from the source of from the alpha radiation with a sheet of paper. Just put it on the way of the alpha particles and you save it. In the air, it will go like few millimeters in the air. Now,
But gamma has a very high penetration.
we'll come to that. Do you know that, do you have a fire alarm at your home?
Yep.
At the ceiling? And there are a source of alpha radiation. That's how it works. There is a source of alpha radiation and there is a detector. As soon as alpha particle hit in detector, it's quiet. But if there will be smoke and it comes into there, it stops alpha particle from hitting the detector and alarm goes off. Is it dangerous to have this source of the nuclear radiation, in this case alpha radiation, at home? Is it dangerous?
No.
No, it will not get out of the detector. It has very low penetrating ability. The only one case when it can become dangerous if you for some reason you decide to eat your fire alarm and it will get inside you and then you will have a source of the alpha radiation inside you. Yeah, that will be
Is that
very
bad?
bad. Yes, it will be pretty bad. So don't eat your fire alarm.
It become radioactive.
No. Beta. Beta, its electrons moving fast. But it's much, at 8,000 times lighter than alpha particle. So ionizing is like medium and penetrating is medium. Penetrating ability medium as well. You can protect from the beta radiation with a sheet of aluminium. Like thin few millimeters of aluminium will stop beta radiation. In the air, it can go a few meters in the air. And gamma radiation, because it has zero mass, pretty much, because it's electromagnetic wave, it has ionizing low, very low, so still can do, but penetrating is huge.
Very, very high.
To stop the gamma radiation, you need to either lead or few meters of concrete. Through this, our building, through school, it can go easily through the whole building. It's not thick concrete walls. So like 5 meters of concrete will stop it, or lead will stop it. And that is
What about the positron?
same as electron.
Same?
Because positron is same as electron except it's positively charged.
Okay.
So that's what I wanted to explain today. Double check that I have explained totally about everything that I wanted. Yep, that's all for today. Except one more thing. It could be that we have unstable nucleus. It decayed. But the result, the product, might be unstable as well. And it's another decay. So, but you cannot decay, for example, at the same time, it cannot be ejected two alpha particles. So it can be ejected one, a new nucleus can eject another one, but not necessarily alpha. So it can be not always going alpha. It might be alpha decay, then beta decay, then alpha decay, then couple beta decays. So there are some actually decay series, which you have worksheets. We will look out how the decay of uranium works, the series, decay series, and decay series of thorium. But that's usually on the practice. That's all for today. Like, subscribe, and donate to help fight Russian terrorists, support Ukraine and Israel.